Hey, Halle. I hope you're doing okay. I'm going to go ahead and go over, this is the review B, number 12. I hope that this will help you. This is about the type of problem that I'm expecting you will see on your test tomorrow. Not quite as hard as review A. So let's just go ahead and get started with this. It says, the problem says to find G of f of x. So what we're going to be doing is instead of writing f of x here, we're going to write what is in f of x. So we're actually going to solve for g of 1 over x plus 2. And what that means is to take whatever is in here and put it in place of our x there. So it's going to equal 3 times 1 over x plus 2 plus 5. So all we have to do is distribute our 3 to both of those pieces, or just to this. So we have 3 over x plus 2 plus 5. Now we're not quite finished because I can't just add without having a common denominator. So I see that my common denominator is x plus 2. So I'm going to go ahead and multiply x plus 2 by the top and the bottom of my other one here. So I end up with 3 plus 5 times x plus 2 over x plus 2. And then when we simplify that, I get 3 plus 5x plus 10. All of that is over x plus 2. And then we simplify that and we end up with 3, whoops, not 3, we end up with 5x plus 13 over x plus 2. And that's all you have to do. So we just take what is in f of x and substitute it into our g of x. And that's all you have to do. All right, so let's look at number 14. That was the other one that you thought was kind of hard. So let's see if I can get you there. Okay, 12, 13, 14. So on this one, let me just go ahead and do this one for you real quick. Okay, again, this one says determine by composition. So what that means is to find out if they are inverses, what we're going to do is we're going to say, okay, f of g of x, and if that equals x, and g of f of x equals x. So if both of those equal x, then they are inverses. If they don't both equal x, then they are not inverses. So let's do the first one. Let's do f of g of x. All right, so that says what is in g of x here? So it's actually going to be f of, and what is in g of x is 3x plus 6. And f of x was negative 1/3 x minus 6. So everything I see here has to go into this x. So I'm going to end up saying negative 1 over 3 times 3x plus 6 minus 6. So now when I distribute this negative 1/3 to everything, I end up with negative 1x plus negative 2 minus 6. So I end up with f of g of x equals negative 1x minus 8. Now notice negative 1x minus 8 is not, it is not x. All right, and so that tells me these are not going to be inverses. If it had been x, then I would have to do the same thing with g of f of x, and if that ended up also being x, then I would say yes, they are inverses. But in this case, they are not, because f of g of x does not equal x. So I don't even have to do the other one because I can already tell that they're not. Okay, so let's look at number 15 now. 15 says to use the constant differences or ratios to determine the parent function which would best model the data given. Okay, so on this particular problem, we're just going to do constant differences and constant ratios. So let's just go ahead and look at this one. Now, first of all, I'm going to look up here, and 1, 4, 9, these are not constant even up here. All right, and so this actually ends up being a square root. You're not going to have a problem quite this difficult. Your problem for your test is going to be, these are all going to be constant. All right, so it would be something more like this. All right, so the first thing we would do is check the constant differences. So we just say 16 minus 13, well, that's 3. 13 minus 10, 3. 7 minus 10, 3. So all of these are 3. So the first constant difference is, or the first differences are all constant. So that tells us that the best parent function that would best model this information would be a linear. All right. If, let's suppose that you had been given some numbers and the first differences ended up being this row right here. So this row would have been the linear. This row then would have been the second row. And so in that case, it would have been quadratic. Okay, so, and then if it had been down to the third set of differences, it would be cubic. And if you had to go all the way to the fourth, it would be quartic. Now, if you don't get to anything doing that, you can also try your ratios. So you try 16 over 13. Or actually, let's try them the other way around. We would say 1 over 4, 4 over 7, 7 over 10, 10 over 13. Okay, once we do that, if we get the same thing, say 1.25, 0.25 every time, 0.25, then we know that the ratios are constant, and if the ratios are constant, it's going to be exponential. That's going to be your best parent function to use, would be exponential. So the answer on these problems is either going to be exponential if you see that the ratios are constant. If you're looking at the differences, if there's the first difference is linear, second difference quadratic, third difference quartic, and fourth cubic, and then quartic. So that's all your answer is going to be, is one of those 5. And so that's all you have to do to find the answer to those. All right, so I hope that helps you answer your questions. If not, send me another message back and I'll try and do a couple of more for you. All right, I will see you in class tomorrow. Good luck, have fun studying, and see you tomorrow. Bye.